So let's do the old hanging light question. So this would be like a stoplight. I guess I could do like green and red here to make it clear. This would be like a stoplight question. And the first question we need to ask ourselves is, well, what am I looking at? So if you're asked for these two tensions and you have this line here, this tends to mess people up a lot. So I'm just off to the side here. Let's think just in terms of what's happening here. That from the light's perspective, so here's the light, then here's my free body. Let's see, I have the force of gravity straight down, and I have this force of tension straight up. And that's it. So these two forces are exactly equal. So if I say that up and to the right are positive, then I say, so the force of tension minus the force of gravity, well, that equals 0 because it's not falling. So then the force of tension must equal the force of gravity for this line. And I'm saying that because one of the ways you can look at this is just redraw it, right? We can go like this. We know what these two angles are. That this picture for solving anything is exactly the same as that picture because this is true. So we don't actually care about what's going on this line because that's exactly the same as the weight of the light hanging itself. So here's my 32 and here is my 26. So let's do a free body for that. So here is my light. It has the force of gravity coming down. We'll call this 1 and this 2. So I have this force of tension 1 kind of going up like that. And then I have this force of tension 2 going up like that. And then here comes the part that freaks everybody out. They're like, wait, I'm used to taking things from like this angle. So coming, if I take the gravity straight up, and some of you will do that and you'll be totally comfortable. You'll be like, well, this is 90, so I can figure out what this angle is here. And this is 90, so I can figure out what that angle is there. You can certainly do that. And all I'm going to tell you here is that it doesn't matter. It does not matter. Neither approach is incorrect. If you want to do that addition and go from an angle straight up from gravity, totally fine. The other thing I can tell you, though, is if I look at this picture, let's see, what do we have going on here? I have a y component from this. So my y component from both is going straight up. It's going to, these two y components are going to sum to the gravity component because the gravity is all in y. And then I have this force tension component. So I have force tension in the x for 1. And then I have this force tension component going like this, force of tension in the x for 2. So my y component is straight up the middle. That's balancing out the force of gravity. And then I have these two x components going equal and opposite directions. So I can kind of work off of this and let this be my guide, right? Because I know what that angle is. So if I used this angle, totally fine. It's going to balance out. There is no wrong answer. I'm going to choose to use this angle just for fun so we can kind of see how that looks. Let's see. Worried about running out of space here. So let's go with a sum of forces in the x. So how does that look? Let's see. I have the cosine. So this is touching this angle. I've defined this direction as positive. So I have a force of tension 1 cosine of 32 minus, well, this one is going in the opposite direction of what I've defined as positive, because remember I defined positive as to the right. So this is to the left. So minus force of tension 2 sine of 26. And what does that equal? Well, this whole system is in equilibrium. It's not moving. So this equals 0. There's 1. So I can look at this. I'm like, oh, that's nice. I can go force of tension 1 cosine of 32 minus, oops, 1 minus force of tension 2, or equals force of tension 2 sine 26. So I look at this. This is kind of key, because once I do my next one, which is kind of ugly, I see that I can solve for either force of tension 1 or force of tension 2 in terms of these angles. So let's see how that looks. I'm going to move this up here for a second. Let's do my sum. I'm going to rewrite my sum in the x with a pen that's not dying. So let's see, we have my sum of forces in the x is force of tension 1 cosine of 32 equals force of tension 2 sine of 26. Now let's do the sum in the y. Let's see, so the probably easiest thing to fall for here is to say, well, they're both going up this way, so you only do one force of tension, but this is actually both of these cables. So you need to have a force of tension in the y for this cable and a force of tension in the y for that cable. So I should have 3 pieces total. So let's see. This one is opposite, and this one is opposite. I've defined up as positive, so both of them are going to be positive quantities. So I'll have force of tension 1 times opposite is sine of 32 plus force of tension 2 times sine of 26 minus 26, sorry about that, minus the force of gravity. So this is the light hanging by itself. Remember, it's all on the y. And again, this thing isn't moving, so that is 0. So I look at this, I'm like, okay, I have 2 unknowns. If I have 2 unknowns, I must have 2 equations. I have 2 equations, I'm good to go. So if I know this, I can solve for any of these. It's kind of nice. So I can go like this. I can be like, okay, so force of tension 1 equals force of tension 2 sine of 26 dividing by cosine of 32. Be careful here because I didn't give the same angle. So if I gave the same angle, this would be nice because sine over cosine is just tangent. So it becomes a little neater. But of course, I mean that way. So we are doing it with 2 different angles. All right, so what I'm going to do is substitute this statement for force of tension 1 into this equation. So I'm going to substitute this whole chunk here, and that will give me this whole piece here in terms of the force of tension 2. So let's see. So I get, putting this into here, I get force of tension 2 times sine of 26 divided by cosine of 32. So I put that in there times sine of 32. Ooh, that's exciting. Because this times this, well, that's, or that divided by that, that's just tangent. So that simplifies that piece down kind of nicely. And then plus force of tension 2 times sine of 26. And what I'm going to say is that I've given you the weight of the light. So I'm going to move the force of gravity over to the other side. So it's the mass of the light times the acceleration due to gravity. So when I look at this, I'm like, okay, I can rewrite it and make it a little neater. Sine of 32 over cosine of 32 is force of tension 2 times sine of 26 times tangent of 32 plus force of tension 2 sine of 26 equals mg. Cool. Now what I can do is this force of tension exists in both terms. So the name of the game here, the reason why I moved this over is that I have these 2 variables here. So if I can get everything with whatever variable it is that I'm interested in on one side of the equation, I can factor it out and then solve. So I can factor out my force of tension 2 times sine of 26, tan of 32, plus sine of 26. And that whole thing equals mg. So now, last step, this thing here is like x times y. I can divide by x. So I'm going to divide all of this over to the other side. I get force of tension 2 equals mg divided by sine of 26, tan of 32, plus sine of 26. Cool. That's it. So that would give me force of tension 2. So what's nice about this is once I have this value, this force of tension 2, this is, what you've just solved for is the hypotenuse. You solved for this whole tension, not just a component of it, but this is that entire tension on that line. So I come back here, remember when we did that step and it was just the two of them? Well, look at this. Well, that's what I rewrote here. So now I have a value, and these are just values. I can plug this in here, put a numerical value there, and then suddenly, boom, I know what this tension is. So with two unknowns and things at an angle and not sure how to solve for them, just by using our summation of forces, a little algebra, we were able to simplify it down to solve for the force of tension 2. Use that to solve for your force of tension 1, and you're done. Just like